This is River Currents. Float downstream with us as we follow current issues in the Susquehanna River Basin.
Hi there and welcome. I'm Stacy Hanrahan, Communications Specialist here at the SRBC, and I'm excited to tell you a water-saving success story today. You may be surprised to learn that some water distribution systems lose as much or even more than 60% of their potable water to leaks. Aging infrastructure combined with outdated detection methods is only making matters worse for your local utility. Asterra, formerly Utilis, is a company applying cutting-edge technology originally used to find water on Mars to now detect underground water leaks in your neighborhood. One of those neighborhoods benefiting in the Susquehanna River Basin is Kline Township in Schuylkill County. After just one application, Asterra's satellite-based program is expected to save this small rural utility tens of thousands of dollars per year. Here with me to explain is Bruno Tume, Sales Manager for Asterra, as well as Karen Pollock, Senior Engineer for Systems Design Engineering. That's Kline Township Municipal Authority's consulting firm. Thanks for being here today, guys. Bruno, let's start with you. Just explain to us how this technology works. Satellite-based, right?
That is correct. And first off, I wanted to say thank you for having me, Stacy. It's a pleasure. That is correct. We are using satellite-based technology to detect essentially soil moisture in a number of different areas. Asterra actually uses patented technology for infrastructure condition assessment, for pipe replacement modeling, and for leak detection in urban and rural areas. This can be done both on the potable water side. This can be done on the sewer wastewater side as well. Although for this specific service that we did with Kline Township in Pennsylvania, this was done on the potable water side. Now, what we are using is very, very unique. No one else in the industry is doing this. No one is using this. And what we are using is actually called L-band synthetic aperture radar. This is a radar. It's remote sensing technology. Remote sensing being we are here on Earth while the satellite is up in space taking images all over the world. So we do have worldwide coverage of this. We've got a number of projects as far as Italy, the islands, the Northern Mariana Islands to the Bahamas, and in your Kline Township, Pennsylvania area. So very awesome technology. L-band synthetic aperture radar is actually being mounted on these satellites. These satellites are able to carry a sensor. And so that's what we're doing is everything is sensor based. Now with L-band is actually a wavelength in the magnetic spectrum. There are many different bands out there, but the reason why we've chosen to use L-band is because L-band allows us to penetrate the Earth's surface. We know utilities like Kline are able to find reactive leaks very simply, meaning walking by and you see the leak coming to the surface and you can now address it. A main break happens and you can now address it. But with that being said, what happens to all of the small leaks, the small pesky leaks that aren't going to come to the surface? They could be leaking for 20 minutes. They could be leaking for 20 years. And you don't even know about it, right? So with us being able to use this L-band synthetic aperture radar, we're able to detect non-surfacing leaks. Actually, about 90% of the leaks that we find will be subsurface in these projects. So that's a little bit of the technology. And I can talk about the algorithm a little bit later on if you'd like, but I'll leave it at that for now.
Yeah, so tell us just briefly, because I think it's fascinating how Asterra got started. I mean, your top guy was using this technology on Mars, and now here we are using it in our backyards.
Yes, very, very crazy. So our chief technical officer or CTO, his name is Loren Guy. He was actually a part of the NASA space mission, like you said, that used this technology to find water on Mars, which is very, very, very crazy, right? And obviously they were successful in doing that. And they thought, well, if I can find water on Mars using this technology, why don't we simulate some leaks on Earth and try to do the exact same thing? And they were successful in doing that. So needless to say, I wish my name was Loren Guy. He's obviously doing pretty well. But that is how the technology started. We actually, once Loren found that this was going to be successful on Earth, there was a lot of testing being done between 2013 and 2016. In 2016, the company was actually then beginning projects worldwide. And so that's where we are today. We've now done well over 650 projects worldwide. And that's how the technology really first started and how the company came about. It started off as being just a leak detection company, one application for leak detection, to where we now have many different applications that this can be used in.
So getting back to the technology, you guys don't own the satellites, right? You purchase or get images from the satellites and then you interpret it. So kind of walk us through the process of, a township signs a contract with you. What happens next?
Absolutely. That's a very good question. And you're correct. We do not own the satellite, Asterra. That is something we're looking forward to in the future. When? I'm not sure, but we do plan on potentially owning our own satellite. But today we are using a commercialized satellite, actually two different types. One is called ALOS 2, which is a Japanese satellite. And then we're using Salcom, which is an Argentinian satellite. And so, like you said, what we're doing is simply going to these companies, purchasing the imagery, and our expertise, our analysis is in that imagery and what we can do. So we have engineering teams, we have AI teams, we have a lot of different data teams that are able to analyze these images. So to put this into perspective, how does it work? So Kline Township, for example, or any water utility out there or engineering firm would need to come to us and say, hey, we want you to scan an area and produce the analysis for us. So that's what was done here. I spoke with Karen, with Aaron. They said, hey, we'd like an image of Kline Township. So we went back, we took that imagery using one of our two satellite images. These images can cover up to about 1,400 square miles in a single image. It's about 30 miles east to west and about 20 north to south. Excuse me, vice versa. It's about 20 north to east to west and 30 north to south. So it's a very large area. You can imagine we can cover Kline Township and neighboring utilities all in a single image. So what was done is we took that image, and all of the algorithm and analysis is done by detecting soil moisture. That is what we're looking for at the end of the day. So, the application is used for leak detection, but I almost don't want to say that we're seeing leaks per se. What we're seeing is actually soil moisture. And we're overlaying that data on top of the utility's GIS. So using whatever GIS the utility might have, and don't get me wrong, some don't have GIS at all. Some might also have partial GIS of the system. This is okay. The more information that we have and knowing where those pipes are, the more accurate our data is going to be. We want to produce back soil moisture where there is pipe indicating leakage. So what we're doing is actually analyzing that soil moisture.
So you get an image, you find locations where you're seeing the soil moisture. Then what happens? You pass that information along, and they just go find the leak and fix it right away. How does, walk us through that? I think you call them points of interest.
That's correct. Absolutely. So we'll get that imagery, and what we look for in that imagery is actually the pixels within that imagery. So with SAR data, when you get a satellite image back, it's extremely noisy, it's extremely messy. And so what we need to do is clean out that noise. You can imagine when we're working in space, we're having to overcome a lot of interference, such as cell towers, airports, things like that can influence the image. So we actually look at this pixel by pixel, look for that soil moisture. And so it's an actionable data for the utility. We take that and turn it into exactly what you said, points of interest, or another term could be used, likely leak location, LLLs. So many acronyms out there, but we need to give the utility something actionable that makes sense. So we'll actually highlight that area or point of interest. It's about a 300-foot radius in length. That's about how close we can get to, I don't want to say a leak, but really soil moisture in general. We produce that back as really a shapefile or GIS data set back to the utility so they can integrate that information into whatever software that they're using. Now, for those that aren't necessarily super technologically advanced, maybe don't have GIS, we can produce back leak sheets of these points of interest. It's very simple, just a piece of paper essentially showing them the highlighted pipe segments that we're seeing in that 300-foot radius, the point of interest. It's got an address, so they know exactly what house to begin with and how many assets being the hydrants, the valves, the meter boxes, things like this. that an acoustic leak detector would need to go and do acoustic leak detection on, which brings me to another point in the project that is very important. Is there's two steps. Right? One is Asterra and the data that we provide. We take a satellite image, we produce back points of interest. Second is acoustic leak detection, doing pinpointing and verification of the data in the field. There are a number of ways to do this. There are a number of different technologies out there that you can use to do acoustic leak detection. Again, we can only get so close from satellite imagery, right? We're taking a satellite image from almost 400 miles above us on Earth. And so we can only get so close, again, about a 300-foot radius. And traditionally, what's being done and what Aaron may have been doing in the Kline Township area prior to Asterra is just walking the field and looking for leaks, sending a team out there to walk the city and look for leaks. Essentially, they could be using various equipment. They could some use just the human eye to look for those leaks that pop up on the surface. They could be using correlators, which is a machine where you're putting a stick in point A, one in point B, and looking to figure out where the distance is of that leak between the 2 points. There are so many technologies out there. And the thing is, we Asterra still need them.
And a leak detection dog. I saw you have one of those.
Very, 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 very cool. So there is a leak detection dog. That's actually being done in central Arkansas. You've got dogs being able to sniff chlorines and chloramines to be able to detect leakage. So
wow.
Yeah, there's a lot out there.
But what you're saying is, okay, so the traditional way of doing things that at this point, when you talk about satellite, is going to sound outdated, but it's literally a person walking the whole distribution system, listening for leaks. That's the acoustic detection. And you've got to check the entire system. It's going to could take a year or more to check the whole system. Whereas you guys are with the satellite technology are narrowing the focus in so that you know within a 300-foot radius your best chance of finding a leak rather than having to search the entire system.
Spot
on.
Correct? That is absolutely correct. I mean, for a system like even Kline Township, which is smaller, a lot of the utilities we work with are even larger to where, like you said, they can't investigate or survey a system in an entire year. It takes multiple years. And so why send someone out to walk this system when we can send them to a very small portion of the system to find a lot more? For example, the Kline Township area, the analysis was done in actually about 22.1 miles, but they actually only had to go and investigate 14% of that, 14% of the system to find a lot more leaks, to put that into perspective for everyone.
I think this is a good time to bring Karen in. Karen, for decades, you've been a consulting engineer, a project manager on water system development, treatment, operation, maintenance, everything. You've seen it all. So what was let's call it KTMA, Kline Township Municipal Authority. What were they facing? What were the issues?
So this is one of our municipal clients. They're located in rural Pennsylvania, up in Schuylkill County, in the midst of the coal mining region. On the year before we did this, they were looking at a non-revenue water, and non-revenue water is water, we're producing it, we're sending it out into the system, but it's not showing up on our billing. So it's also called lost water. And the year before we did this, we had 63% non-revenue water, which is huge. That meant we are producing more water than what we're getting revenue for. We know that it was leaking. We knew we had leaks, but as Bruno mentioned, we have a 25-mile system, and we didn't really have a program per se. We would just go out and see what we could see visually, and then cross our fingers that we could listen and find locations of some of these leaks. We listen at the fire hydrants and whatnot. And it was really tough because this area of the country, leaks may not surface at all. We'll get into it, what we found, but none of the leaks where we have the most difficulty is they're just not showing up on the surface. They're following pipelines, and or they're going into the stripping mines, and they just don't surface. So really difficult area to find leaks.
So how did you hear of Asterra?
How did I hear of them? I caught a National Rural Water Association webinar in the summer of 2021, July. Kind of a funny story is, for professional engineers like me, we are required to renew our licenses every 2 years. So we have to get so many hours of education. So webinars are great. So I was scurrying at that point to try to find some hours, and I saw this webinar pop up on the National Rural Water Association website. I'm like, huh, that looks really interesting. And I watched it. I'm like, wow, that's really awesome. Because as Bruno said, if we can save time and energy and narrow down where we are looking, that's huge. It's just huge. So I did take it to the authority because I knew we were, you know, had a lot of non-revenue water. And we were talking a little earlier and giggling that Aaron first laughed at me when I brought it to him. He's like, a satellite? What are you talking about? Get out of here. So luckily, the January after that, we saw SRBC has a consumptive use mitigation grant. I'm like, huh, water conservation, we can do that. So I put
It's a
that
perfect
in
fit,
the
yeah.
grant application, and we received funding. So we were really ecstatic that we could try this technology out. And I gotta say, we were a little apprehensive at first. Is this really gonna work? So we gave it a try, and we came up with some really dramatic results.
So let's get into that. Let's talk about how many scans did you do? When did you do it? I mean, this is all fresh headline news right now that, you know, you just got this done, right? And you're starting to see results. So tell us about it. Tell us what they found and what you're saving.
January 2022 was when the applications were due. We heard back in March from SRBC that we got the grant, and then till all the paperwork was signed, I think it was flown at just before July 1st. And then we got the results shortly thereafter. Mid-July, we had results. And then by the end of July and the first week of August, we had a team out in the field looking at the points of interest. They had, you know, their acoustic equipment, because really you can't get away from that part of it. We get the data, and we have areas that we can look, but you still have to go out and do the boots on the ground is what Asterra calls it. And they went out. We had, you know, put aside 1 week, and we had a third party come in to do that boots on the ground. And our guys were with them. They followed them around. They learned how to do it. And within the first 3 days, we had found from 16 points of interest, we had identified 5 locations of leaks. And then in August, our guys went out and started repairing those leaks. And what we were finding was mostly service line leaks. They weren't big, huge leakers, but there was 5 small, and I'm going to say small, but they weren't small. They add up. They were 5 service lines. And we found after we fixed those, we were saving 125,000 gallons per day. So on average, by the middle of August, we had gotten 4. So 4 leaks we're saving 125,000 gallons per day. That's an average of 20 to 25 gallons per minute, which doesn't sound like a lot, but it really adds up over time. And none of these leaks were surfacing. They were all subsurface, not coming to the top. We couldn't see them. But for Asterra's scan, we wouldn't have.
Meaning, yeah, you may never have found these
right.
leaks, or maybe it would have been years and you would have continued to see the water loss. So
Right.
that's incredible. So
at
within a month.
125,000 gallons per day, we had two of our tanks are 250,000 gallons. So we're saving every 2 days, we're saving one of those tanks. So
Wow.
it's
and Bruno, that
dramatic. And by September, October, we had fixed 2 more leaks. We're saving 205,000 gallons. By that time, we were saving 205,000 gallons. When you look at the energy costs we were saving, our well run time decreased from 18.5 hours per day down to 13.5 hours per day. That's 5 hours per day. We didn't have to run those pumps. So that's 25% savings in energy. We have chemical costs. And in the last 2 years during COVID, chemical chlorine costs went through the roof. They doubled, they tripled. So we're saving 25% savings there in chemical costs per month. We figured, after I looked at the energy cost savings and just the chemical cost savings, when you annualize those costs, we're saving $51,000 per year in those real costs that we were expending. We'll see those savings. So
it's huge for a smaller
it's
utility. Huge. Yeah.
We can buy a mini excavator for that. That's one of on our wish list. So
There you go. There you go.
In a year, we can pay for that.
So do you do it
dramatic.
again? So now that's to remind the listeners again, that was after one scan, one analysis of one scan. Is this something that should be done yearly? Is this something that you'll do again? What's next?
So yes, we absolutely will do this again. As Bruno said, the picture that they get, it's 30 miles north to south, it's 20 miles east to west. That's a huge area. So, and we are only 25 miles of pipe. So what we actually did was at the beginning of September, we invited some area water authorities that are close to us, that neighbor us, that show up in that scanned area. So we got a cost sharing group together. And with that group, we got another proposal from Asterra to do another scan. And based on our prorated share of mileage of pipe, there's one big user in there, they have, I think, 135 miles or 155 miles of pipe. We're at 25. And then we got 3 or 4 other small rural authorities next to us that have different, there's one is 75, one is 35. So based on a prorated share, we're going to do it again. And at that point, it becomes really cost effective when we start cooperating together to do this on, if we can get into a yearly program, that would be really great. What we find in our system is during this time of year, we start to freeze when we come out in the spring and everything starts to thaw. Things are popping all over. If we can get that scan going on in the spring when things are starting to pop, we can spend the summer, repairing those leaks. And, this is something that never stops. Our systems are old. They're 100 years old. There's, 75 to 100 to 150 years old, some of our clients. And, those pipes are at the end of their life cycle. With what we found was the copper pipes at the compression joints were starting to fail, at the flared joints. So we're finding, really a mix of things. It's service lines, it's port stops, we did find one really big leaking main. So it never stops. Where you fix one place today, the neighbor starts failing tomorrow. So it's an ongoing issue.
So it's interesting because it seems to me that, Bruno, with your technology, these utilities are actually finding out more about their system that's so old, that's underneath the ground that we can't see, very well, by fixing the leaks. So by finding the leaks and then fixing them, like Karen just said, she's really learning more about the actual system that's in place, and probably also finding areas that, maybe need more attention first, or prioritizing areas.
Absolutely.
Right?
Absolutely. Spot on.
I'll let you, because getting close to the end of the time, I could talk about this all day. But so Bruno, I'll kind of give you the last word on that. Do you guys have other applications of the technology for infrastructure planning, that kind of thing? Is that kind of Asterra's next step? And also, by the way, I just have to say, I love the whole, we'll give you a deal if you're in the neighborhood type thing. It's like when you asphalt your driveway and they're like, well, if you get your neighbors involved, while we're in the neighborhood, we'll all do it together. I'll give you a discount. That's great.
Why not, right? Economies of scale. We're able to do that. So yes, no, absolutely. There are a number of different applications that we have today that are using this technology. It's awesome. We actually first started the company that was called Utilis, and why we decided to rebrand and change the name to Asterra is for that reason. We don't want to be known as just a leak detection company. We are actually an earth observation company. We have many different applications that this can be used for, and we're actually planning on bringing this right back to the Pennsylvania area and doing it on what we call the earthworks side of the business. This is a completely separate application from our Recover product, in which we use that Kline Township for leak detection. Actually, earthworks can be used in many different critical infrastructure areas. We're talking railways, roads, earthen dams, levees, mining, things like that on property as well, being able to detect soil moisture under even parking structures for planning purposes. So this is something that's being done in a number of different places around the world, and we're planning on bringing it to the Pennsylvania area as well with the SRBC. So that's next steps for us. Another application that we do have beyond just leak detection is actually a pipe replacement strategy. We know that there's aging infrastructure. We know that there's limited budgets when it comes to being able to replace pipe, and not a lot of information is available to make that decision on what segment of pipe you want to replace that year. So we're able to take our data, produce multiple images over a period of time, and give insight to the utility on what areas we see as a problem and what pipe segments we see as a problem, so they can replace that as well. So those are our three applications and verticals today. And of course, with our CTO office and our R&D team, expect a lot more to come in the coming years as well.
Yeah, keep your eyes open for Asterra. I think we're going to be seeing you guys a lot more. Karen, any last thoughts?
Well, I keep saying I'm your biggest cheerleader, because I do see a lot of applications for this technology. It is a powerful tool. It's not a once and done. It's something that you can use in your normal maintenance, because it saves you time. I will say that I think our guys out in the field learned some really good strategies from the third party that came in, that we can use as we move forward. I think the next time our own crews are going to go out and do the boots on the ground work, because I think they have enough confidence after watching and participating with the third party to do that in the future. So there was, more than just the scan. We got more out of it than than just information.
Great partnerships too. I want to thank Bruno, Karen, thank you for walking us through the technology, sharing the amazing results. I really appreciate it. Today, we highlighted just one of many projects that I know us here at SRBC are proud to have funded, focused on improving the sustainability of stream flows and groundwater, especially during times of drought. And we actually have another round of our consumptive use mitigation grants. It's actually open right now with applications being accepted through the end of January. So for more information, we would love for you to visit our website at srbc.gov.
And now you're current on issues of the Susquehanna. Thanks for listening to River Currents. See you downstream.